Now in this case, this is a question based upon the conservation principle. There is a wire CD, it is a wire CD which is basically connected to the rails and it is falling down. Now vertical rails, and there is a uniform magnetic field perpendicular to the plane. So there is a uniform magnetic field perpendicular to this vertical plane given as B. Now they are asking find the velocity such that the CD moves with a constant velocity. So my dear students, basically this CD moves with a constant velocity. It is given to us. So when this CD will move with constant velocity, this is what we need to find. How do we find this? So there is a very simple concept, conservation of energy. Conservation of energy, or you can say Lenz law. So as it goes down, you know, the gravity will do a positive work. So energy transferred by gravity, energy transferred by mg should be equal to, so due to which, you know, there will be EMF induced across this V cross B, EMF will be induced like this plus and minus, and there will be current in the circuit, and due to which electrical heat will be generated, electrical heat in resistance. So this is the concept we are going to use, conservation of energy. So at a steady state, the work done by gravity per unit time or the power transferred by gravity will be same as the heat generated in the resistor. So basically this is equal to I square R, and the energy supplied will be force mg into velocity. From here you can directly get the velocity. How will you get the I? I is nothing but BLV by R. So put the values here. This is equation number 1. So what you get is mg into V, mgv will be equal to I square. So I will be equal to B square L square V square by R square times R. So this R gets cancelled out, this velocity also gets cancelled out, one of the velocity will remain, and the velocity will be, you can see, mg R upon B square L square. So this is your answer, mg R upon B square L square. Again a beautiful question. Some of you might be thinking, sir, we could have also done it using dimensional analysis. Yes, that can be done also, but you must know the fundamental concepts as well. When the speed is constant, the work done by external agent must be equal to the heat produced. That is the Lenz law, that is the conservation of energy principle. So that is a method in using which we can determine the steady state speed of this. Now this is again a very good question. So there is a rotating rod about this center, you can clearly see, and AO is L and OC is 3L. So this length is L and this is 3L. Now this time we have different radius, and we have to find the potential difference between O and A. So if we assume this as a reference, potential at, we know this is the reference, by taking this as a reference 0, we know the if it is rotating like this, the velocity will be like this. So V cross B, so it means the direction of V cross B is this, so this is high, so C must be negative, and as I told you, potential difference across both the sides will be of same sign, so this is also negative. So clearly you can see this time the center will be at high voltage, okay, and how much high? So you can clearly see the distance is 3L, so this is B omega times 3L square by 2, and this is B omega times L square by 2, that's all. So we know this is the reference point O is the reference, A and B. Now we can calculate VA minus VO. VA minus VO. So what is VA? VA is minus B omega L square by 2, and what is VO? 0. So you can see this is the answer, and in this case it is given as plus, so this is wrong option. Now let's go to second option, VO minus VC. So VO minus VC will be equal to 0 minus C is B omega into 3L square by 2. So this will be plus 9B omega L square by 2. So 9B omega L square by 2, this is again also wrong. Now let's go to the third option, VA minus VC. VA minus VC. So VA is already we know is minus B omega L square by 2 and BC will be minus 9 by 2 B omega L square by 2. So clearly from here you can see 9 minus 1, so 4 B omega L square by 2 positive. Yes, this option is correct. Similarly, you can determine the fourth option will be wrong. So this is how we do. This is a complex problem in which we have determined taken always this as 0, but now because the direction of EMF comes out to be positive towards the O, it means the end point must be negative because we have chosen the origin as 0. Next question. This is again a previous year question, very good question. So basically there is a long current carrying wire I, this is carrying current I, and we have a loop of length L or side A at a distance x and moving with velocity v. So my dear students, if you can recall, we already, the first problem of this topic was this one only, but there was a magnetic field was uniform. Now in this case the magnetic field is not uniform, my dear students, because the magnetic field will decrease as we move away from the center, and the magnetic field will be equal to mu naught I by 2 pi times distance r. So in this case, due to which this would have a higher voltage and that would have a lower voltage, and the effective EMF will be E1 minus E2, and we know there will be no potential difference across these horizontal lines because they are, the velocity will be along their length, so no EMF in these rods. So the net EMF, the EMF induced in the frame, net EMF will be E1 minus E2. Now because velocity is same, so this will become magnetic field at position 1 into length is A into V minus magnetic field at position 2 into AV. So when you put the value of magnetic field, this will become mu naught I upon 2 pi times A times V into 1 upon, what is the distance of first? So if you can see, if I write the distance of the first one, it will be R1 will be equal to the total distance x is given from the center, and this is A by 2. So R will be equal to x minus A by 2 R1, and similarly R2 will be equal to x plus A by 2. So by putting the value 1 upon x minus A by 2 minus 1 upon x plus A by 2. Now this will be a constant, so we have to ignore, because you know we just have to find the proportionality, so we don't have to worry about the constants. So I am just writing the expression. So this will become x minus A by 2 into x plus A by 2, and in the numerator it will be x plus A by 2 minus x plus A by 2. So x gets cancelled out and we get A. So when you rewrite this, this will become A by 2 plus A by 2 will be A upon, in the denominator you will have 2x minus A into 2x plus A times 4 into some constant k. So this will be your EMF. So clearly my dear students, you can see that EMF is proportional to, you can see that EMF is proportional to 1 upon 2x minus A into 2x plus A. So 1 upon 2x minus A into 2 plus A. Beautiful question again, previous year problem from your exam. Again, so in this case we have a circular, semicircular loop which is rotating in a uniform magnetic field, and you have to find the potential difference or EMF induced in this. So my dear students, whenever there is a rotation, always connect the center, the reference point, with the end point, and this is how you can get the value of L, which is rotating with omega. So in this case L will be equal to 2R, twice of R. So EMF will be equal to B omega L square by 2. So this will be B omega 2R square by 2. So 2B omega R square. Directly you can solve. So you know how we solve the questions of different diagrams. If you just understand the basic points, that what is the absolute meaning of a terms in a given formula, then the problems will become simpler to you to visualize, to solve.